Okay, on your calendar, you need to change your objective to say this. It's written wrong. Also add to your homework that for 7 through 12, you're going to list these 6 properties. Okay, I wrote out the 6 steps for graphing, so make sure to have these 6 steps down. The order is not important, but if you go in this order, starting with 1 and working your way down to number 5, it will help keep you organized and make sure you have everything for your graph. So you should have these 6 steps written down. If you're watching the video, pause it now so you can write them down. We're going to use the 6 steps to graph these 2 warm-up problems. So for number 1, I'm going to start with the asymptote, which is at -3. So I'm going to draw my dotted line at -3. When you write the equation for the asymptote, you have to write y equals. It is a line. The only way to show it as a line is to write y equals. Now I'm going to find my key point. When we graphed parabolas and absolute values, our key point was the vertex. Well, with an exponential, we don't have a vertex. So our key point we get by making the exponent 0. So what x value makes the exponent 0? So I'm going to look here, and it's -4. And I'm going to plug that in. So -4 minus 4 is 0. So now anything to the 0, 1/2 to the 0 is 1. 4 times 1 minus 3 equals 1. So my key point is at -4, 1. Then I'm going to find my y-intercept. That's going to help me figure out which way or how steep my curve is going to be. To find the y-intercept, you always make the x value 0. And simplify. When you have a fraction to a power, that power goes to both numbers. So we have 4 times 1/16 minus 3. When we multiply fractions and a coefficient, I'm going to think of it like this. 4 over 1, because I multiply across the top and the bottom. So that's going to give me 4 over 16, which reduces to 1/4. And then 1/4 minus 3, well, I need a common denominator of 4. So this is 12. 1 minus 12 is -11/4. So now I'm going to estimate where that is on my graph. -11/4 is a little less than 3, because 12 over 4 would be 3. So 11 over 4 is a little less than. So it's about there. And now I'm going to connect the dots in a nice curved shape. It would help if I actually made it through the points I plotted. There we go. That fits. This 1/2 means it's a decay graph, and this shape is a decay. Okay, now to fill in the properties. The domain is the x values. That's all real numbers. Our range, in this case, every y that's greater than -3. I found the y-intercept already. And now the end behavior works the same way as it has on all of our prior graphing units, except for this one, the right end behavior, as x goes to infinity, y goes to, and it's actually going to approach a number now instead of just infinity. Because as x goes to infinity this way, our y value is approaching the asymptote, which is -3. But as x goes to -infinity, to the left, the y value is approaching +infinity. Now for number 2, I want you to pause the video and try it before you watch me do the problem so you have some good practice for the quiz that's coming up next week. I'm going to start by finding my key point, and that's what makes the exponent 0. So in this case, my key point and my y-intercept are going to be the same exact point. So this is going to be -1 plus 2, which is 1. So my y-intercept's at 1. My key point is at 0, 1. Same spot right there. My asymptote is at 2. So y equals 2. And now because my key point and the y-intercept are the same, I have to use some of my other knowledge to actually get the rest of the graph. This 1/4 means it's a decay, and this negative means it's a reflection over the x-axis. So if I was going to think about what a decay looks like before I reflect it, it makes that kind of shape. So now if I reflect that over, instead of looking like this, it's going to look that way. Except I should probably not touch my asymptote, so hang on. There we go. So now I'm going to fill in my properties. The domain is still all real numbers. Now in this case, the range is all the y's are less than, whoops, not 0, less than 2, because that's where we stop. For right end behavior, as x goes to infinity, my y values are going towards 2. And as x goes to -infinity, y is going towards -infinity. I'm choosing y as my symbol here because the equation we start with is a y. If you wrote f of x, that's fine. If you write g of x, that's fine. It just has to relate back to the equation we originally started with. Okay, here's 2 more practice problems, so try these and then pause the video, try these, and then you can watch me go through the solutions. So for number 11, I need to choose -3 as the x value of my key point. When I plug that in, I'm going to get 2 times 1/2 to the 0, which is 2 times 1. So I'm going to plot -3, 2. My asymptote's at 0. Now for my x-intercept, I'm sorry, my y-intercept, when I plug 0 in for x, I get 1/2 to the 3rd. So that's 2 times 1/8. And 2/8 reduces to 1/4. It's a decay function. So the shape of my graph will look like that. Domain is all reals. The range is everything above 0. As x goes to infinity, y is approaching 0. And for left end behavior, as x goes to -infinity, y is approaching +infinity. So for 12, my asymptote's at 0. When I go to find my key point, I need to plug in 4 for x, and I'm going to get negative 3. So this is going to be negative 3 times 2/3 to the 0. Now, for the y-intercept, negative 3, 2/3 to the negative 4th. Because of that negative exponent, I can flip the fraction and make the exponent positive. And now 3 to the 4th is 81, and 2 to the 4th is 16. This is over 1. So when I multiply across, I get 16 on the bottom, and on the top, it's negative 243. So that's a really negative number that I cannot put on my picture. So because it's so low and it's not on the graph, I'm not going to show a y-intercept when I make my sketch. The main's still all reals. The range now, our y's are less than 0. As x goes to infinity, y is approaching 0. And as x goes to negative infinity, y is approaching negative infinity.